All right, here we go. This question is from the 2016 AB International Exam. It's question 3, so as you can see, no calculator is allowed. Just looking at this question, right away I see a graph, and there's going to be some follow-up questions. This is a functional analysis question. This is a really typical question to see on the AP exam. I'd hope that this is going to be a high-scoring question for a lot of students. If this is a place that you're struggling, definitely get together with your calculus teacher, find some extra practice problems, see what you can do. All right, here we go. A continuous function g is defined in the closed interval -8 less than or equal to x less than or equal to 6. The graph of g shown above consists of 3 line segments and a quarter of a circle, centered at the point 0, 2. Okay? Let f be the function given by f of x, and I want to write this up here. F of x is the integral from -8 to x of g of t dt. Alright, so important things. We've got 1, 2, 3 line segments. This guy over here, they said, is a quarter circle. And the center is over here at the point 0, 2. Okay, not too bad. In part A, we're asked to find all values of x in the open interval, -8 to 6, so don't include endpoints, at which f has a critical point. Then we need to classify each critical point as the location of a minimum, a maximum, or neither, and we have to justify our answer. Okay, let's take this all in for a second. This is the graph of g. They're asking us for the critical points of f. F is this other function that's defined as the integral from -8 to x. Okay, well, what do I know about critical points? A critical point is where the derivative equals 0 or where the derivative does not exist. Okay, well, let's find the derivative. F prime is the derivative of this integral from -8 to x f of t dt. The derivative of the integral of a function from a constant up to a variable. This is your second fundamental theorem of calculus. Second fundamental theorem of calculus says when you're in a situation like this, the derivative of the integral of a function from a constant to a variable, the answer is your original function evaluated at the new variable. Did I just do that right? Oh, I blew it. F prime of x is the derivative. This should be g inside here. Sorry about that. Which means that that's g. Totally messy. Sorry, friends. Okay, but here's what we know. F prime is equal to g of x. Critical points, I'm looking for where f prime of x, which is g of x, is equal to 0. Where is the graph of g, the graph that's up here, equal to 0? Well, I can see that that happens 1, 2, 3 times. There's 3 roots. The first one happens over here at -6. The second one happens over here at x equals 2. And the last one happens at 1, 2, 3, 4, 5, 6. X equals +6. At first glance, you might think that you're going to have 3 critical points. But here's where you need to be careful. You were told to look on the open interval -8 to 6, so don't include x equals 6. Now, we're going to keep going here. You're not just told to find the critical points, you need to classify the critical points. What's happening over here at x equals -6? I see that the graph of g changes from being below the x-axis to above the x-axis. So at -6, g, which we know is f prime, changes from negative to positive. Well, what does that mean? That means that f, the function that I don't see, has a relative minimum at -6. If I look at x equals 2, what's happening at x equals 2? My function g, my graph, changes from being above the x-axis to below. So g, which is f prime, changes from positive to negative, which means that f has a relative max at x equals 2. That's it. That's everything that we need to do here. In terms of points, College Board awards 1 point for showing that f prime of x is equal to g of x. 1 point for the critical points. Now be careful, there's only 2 critical points here. If you include the third one, you probably forfeit the point. And then finally, you get the point from your analysis of the critical points. So this is a 3-point question. And hopefully not too bad for you. I'll be back. Okay, well, I was just working on part B and realized I made a mistake and made it all the way through the problem before I realized that. So there may have been an awkward jump here. Maybe, maybe not. All right, in part B, we need to find f of 0. Well, how do we find f of 0? This is the graph of g. Well, we know that f of x is the integral from negative a to x g of t dt. Well, what that means then is that using this definition for f of 0 is your integral from negative 8 to 0 of g of t dt. Well, how do I evaluate a definite integral if I don't actually have a function? This is why they gave us the graph. This is the graph of g. And one of the first things that we learned about a definite integral is that it means area. It's the area starting at x equals negative 8, going all the way over to 0, and I need to find this area. Now, that's going to be a little bit tricky. Not impossible, just a little bit tricky. Let's kind of look at what we've got here. I've got this triangle that's below the x-axis. Areas below the x-axis are considered negative. I've got this region over here that's all above the x-axis, so that area is positive, but it's not a shape that I know. What you can do is you can turn this into more basic geometric figures by drawing some auxiliary lines. So for example, I know that if I draw a line right here, I've got another triangle. Now I still have this shape that I don't really know, but what if I draw a horizontal line going this way? I then have a rectangle, and remember they told us earlier that this is a quarter circle centered at 0, 2. Well, let's put this together. The integral from negative 8 to 0, I need the area for this first triangle. Area of a triangle is 1/2 base times height. So that's a half. The base has a length of 2. The height is 2. Since we're below the x-axis, that's going to be a negative. The area for this triangle is going to be a half. The base has a length of 2. The height is 2. And that's a positive area. The rectangle has a base of 4 and a height of 2. And the area for a full circle would be pi r squared. The area for a quarter circle then has to be 1/4 of pi times the radius. Well, what's the radius? How far is it from this point over to 0, 2? It's going to be 4 squared. You can absolutely leave that as your final answer. There's no need to simplify. If you do want to simplify, that's okay. This negative 1/2, 2 times 2, and the positive 1/2, 2 times 2 are going to cancel each other out. And I kind of could see that visually here, that these areas are equal but opposite. We have 4 times 2, which is 8. 1/4 of pi times 4 squared. 4 squared is 16. 1/4 of 16 is 4. So this is 8 plus 4 pi. And that would get you 1 little point. You absolutely could have and should have stopped here without doing any simplification. And that would also get you your 1 point. Let's move on. In part C, we're asked to find the limit as x approaches negative 4 of f of x divided by x squared plus 4x. All right, well gosh, what are our options here? The limit as x approaches negative 4 of f of x over x squared plus 4x. What I'm going to do is I'm going to look at these parts separately. What's the limit as x approaches negative 4 of f of x? Well, what was negative x? This is the limit as x approaches negative 4 of the integral from negative 8 to 8 of g of t dt. Here's where x equals negative 4. As my x values get closer and closer and closer and closer to negative 4, I'm going to get a more positive area. I'm going to get a more complete triangle. The area from negative 8 to negative 4, I have this negative area. I have this equal but opposite positive area. That limit's going to be 0. What about the limit for the denominator? The limit as x approaches negative 4 of x squared plus 4x is negative 4 squared plus 4 times negative 4. That's 16 minus 16. That's 0. The limit of the numerator is 0. The limit of the denominator is 0. What that means is we can use L'Hopital. So, by L'Hopital, or the hospital, this limit is equal to the limit as x approaches negative 4 of the derivative of the numerator, f prime of x, divided by the derivative of the denominator, 2x plus 4. Well, what is the limit as x approaches negative 4 of all this stuff? That's going to be f prime of negative 4 divided by 2 times negative 4 plus 4. Well, what's f prime of negative 4? Oh, wait, remember? F prime and g are the same thing. So f prime of negative 4 is the same as g of negative 4. In the denominator, 2 times negative 4 is negative 8, plus 4 is negative 4. Finally, what is g of negative 4? I'm going to look at the graph. I'm going to find x equals negative 4. I'm going to find that y value, that's 2. We get 2 over negative 4, which is negative 1/2. You were awarded 1 point for using L'Hopital's rule. Now, I'm pretty sure that that means all of this work here to show that you have an indeterminate form, and then you earned 1 more point for coming up with the numerical answer of negative 1/2, or of course 2 over negative 4. That's 2 points. The College Board recently has gotten very, very picky about their use of L'Hopital. You can't just jump from here to here and expect to get any points. That's not going to work. You're going to have to do the side work to show that you have an indeterminate form, and then you have to apply L'Hopital's rule. All right, that's enough about that one. Let's look at this last one. In part D, we're told to let h be the function defined by h of x equals g of x divided by x squared plus 1, and then we need to find h prime of 1. All right, well, I know I talk about this in class all the time. If you're going to find h prime, or if you're going to find the value of the derivative at a point, you first of all find the derivative. So h prime of x. How am I going to take the derivative of g of x over x squared plus 1? That's right, quotient rule. Quotient rule says low, so the denominator, times d high, derivative of the numerator, minus high, d low, derivative of the denominator, all over low, low, denominator squared. Now find h prime of 1. That's going to be 1 squared plus 1 times g prime of 1 minus g of 1 times 2 times 1 all over 1 squared plus 1, the whole thing squared. 1 squared plus 1 is 2 times g prime of 1. We're going to come back for that in a second. Minus g of 1 times 2. 1 squared is 1, plus 1 is 2. 2 squared is 4. Now this is great, but you still have to figure out what's g prime of 1 and what's g of 1. Well, let's see what's going on here. If I look at the graph, remember this is the graph of g, here's 1, but what's going on at 1? I need to know the value of the function at 1, and I need to know the value of the derivative at 1. Well, let's see, what do I know? The derivative means slope of a tangent line, so g prime of 1 is slope of the tangent line here. Well, because I'm on a line segment, the slope of the line segment is the same as the slope of the tangent line. All I need to do is pick 2 points. So I'm going to take this point up here, 0, 6, and this point here, 2, 0, to go and find my slope. G prime is going to be 6 minus 0 divided by 0 minus 2. Change in y, change in x. We get 6 divided by negative 2, which is negative 3. Write that there. G of 1, what I need is the y value. Here's the point 0, 6. Here's the point 2, 0. I'm on a line. The one that I need is exactly halfway between the given x values. So the y value will be halfway between these y values. G of 1 is positive 3. So let's finish this up. We have 2 times negative 3 minus 3 times 2 all over 4. 2 times 3 is negative 6. 3 times 2 is 6. Negative 6 minus 6 is negative 12. Divided by 4 is negative 3. All right, let's look at the points here. 2 points for correctly finding the derivative using the quotient rule. And this is something I would expect most of my students are going to be able to do very well with. Now, I think things get a little bit tricky around this part of the problem when you need to evaluate g of 1 and g prime, and you go back to the graph and pull everything together. That's a little bit tricky. But your safe stop, as soon as you hit numbers, is right here. There's no need to multiply and then divide. You can stop right here, or of course you can go to the negative 3. Either way, this final part of question number 3 is worth 3 points. Hope you did well. There were definitely some parts of this question that were straightforward, and then there were other parts that were tricky. So learn as much as you can from the experience, pick up your points, and move on.